Ran out of time on the last one. All right. All right, cool. Now the last thing. Now this is the hardest part. You can never have square roots in the denominator. So just like every fraction, you can always manipulate fractions. You can multiply the numerator and denominator by the same amount, and it still stays as a balanced fraction. So root 7 over root 2, you can't simplify anything with the 7 and the 2. So you're like, well, how do I get rid of that radical? You turn it into a perfect square. Now, if you can remember that trick with the 17s earlier, or like the square root of smiley face times the square root of smiley face equals smiley face, right? If you can remember that trick, that might make this a little bit easier. So if I want the square root of 2 to be perfect, I can always multiply it by itself, times root 2. Now if we do that in the denominator, we have to do it in the numerator. So again, you can remember the trick. Root 2 times root 2 is just 2. But for the sake of this one, I'll write it as root 4 initially, in case you're looking back on this and you're like, how do you get the 2? Up top, 7 times 2 is 14. We'll take our perfect square. The square root of 4 is 2. Check if there are any perfect squares in 14, and there aren't. So it's just root 14 over 2. That would be our final answer. Now, one option for b is to multiply it by itself, and I'll show you two options here. So we can multiply it by root 8n in the numerator and denominator. And when we do that, we would get root 56n up top, and we'd get 64n squared in the denominator. And then you're like, square root of 64n squared is 8n. 56 does have a perfect square in it, though. 4 goes in there. It's 4 times, let's see, 28, 14. 4 times 14n. The square root of 4 is 2. Let me move myself out of the way here. So the square root of 4 is 2, so we'd have 2 root 14n over 8n. And then if you look at the numbers outside, we have 2 over 8. We can simplify that. The fraction 2/8 would be 1/4. So we'll turn this into a 1, this into a 4. So our final answer would be root 14n over 4n. That's one way you could get the answer. The other option is to just turn it into a perfect square. We turned it into 64n squared, but 8 goes into 16 as well. So to get it to 16, you can just multiply by 2, and then we need an even number of n's, so we can multiply by 2n. If we do that up top, or on the bottom, we got to do it up top. So that would turn the denominator into 16n squared. The numerator would be root 14n. Square root of 16n squared is 4n. 14n doesn't have any perfect squares in it. You'll see, same answer, a little bit less work. So if you can think of a smaller perfect square that you can get, go for it. I've also seen it where they break out the perfect squares out of 8 first. To me, that's just the most work. So I would recommend against that. But I can show you that sometime as well. Go ahead, pause it, try it. I'm out of time on this one, so I'm going to have to start the next video. But try them out.